So, this class we will see this environmental studies with reference to port projects. We will be doing two types of environmental study. One is called as the rapid EIA. Please do not talk, they are switching off AC itself because of noise, do not create noise. One is called as rapid EIA, another is called as comprehensive EIA. Hello, do not talk here. That black shirt, you get up, you go out of the class. Get up here, you are talking, I am telling do not talk, yourself only. What is the difference between rapid EIA and comprehensive EIA? Huh? Huh?
Rapid EIA is faster.
Faster. Then?
Less comprehensive.
Less comprehensive. I told in one of the class what is rapid EIA and what is comprehensive EIA. Comprehensive EIA means you have to do for 1 year. Rapid EIA is you have to do it for 1 season, that is about 4 months, right? It is not fast and all, only the duration is less. Rapid is for 4 months, comprehensive is for 12 months, that is for some seasons, either non-monsoon season or monsoon season, northeast or southwest, like that. So, another important thing what you have to do is, for all this EIA study we need to have what is known as a baseline data. Baseline data means you have to compare with the baseline data what happens later. So, even if the baseline data itself is very not acceptable, no point in blaming the developer. Baseline data means before construction of the breakwater or any activity, what is the parameters that has to be first collected. Then you cannot build the breakwater and then measure, that is only monitoring. What you have to do is, when you do the construction of breakwater or earth structure or a dredging, what happens, you have to predict and then compare with the baseline data and see whether it is acceptable or otherwise. That is the second stage. There are 3 stages. One is baseline data, then you have to do some study, it can be numerical or experimental, then you have to do the monitoring. Monitoring is post construction. Baseline data is pre-construction. Study means what are all the structures you are going to build, based on which what will happen to the baseline data that you are going to predict. Monitoring, whatever predictor is within the limits that you are going to see. This is what is known as EIA. But after doing this study, you have to do environment management plan. So, you have to propose the environment management plan to see that the parameters are within the limits. So this EIA study is for both mitigation and environmental management. So, most port development projects disturb the local environment one way or other and needs EIA and EMP studies. So, important is baseline data, this is to be ascertained and fixed prior to the commencement of the project. What are the studies that are required? We already studied this bathymetry, seismic and other mathematical model studies, and we have to study the geography, the morphology and the details of port construction, including type of cargo to be handled. So, what here we are doing is, during the construction stage how the environment will be disturbed, that is one part. Another is when the cargo is handled, how the environment will be disturbed. These are the 2 different aspects which has to be studied carefully. During construction phase, the permissibility of this turbidity and other things can be, permissible levels can be higher, whereas when you are handling the cargo, the levels will be lower. So, you have to collect the baseline data at the project location prior to commencement of construction activities. There are 3 types of studies we have to do: physical, chemical and biological aspects. Physical, chemical and biological aspects, these are the 3 data that is to be done. What are the physical parameters? Wind, storm, waves, current and tides. This can be measured, or this also can be predicted based on numerical models. Typically we measure the tide at a particular location. Very important projects, we measure the waves and current. Actually current and tides are together, we can do the measurement. Waves we can either measure or we can also predict. Important project, we measure the waves. Storms and all, there is a method by which we can predict the storms. Another important thing for wind and storm is, at least for wind 100 years and for storm about 60 to 70 years, we have the data, what is the storm that has happened earlier, what is the maximum wind during cyclone which has happened. So, the historical data can be collected. Last class we discussed about the littoral drift. The salinity and temperature can be measured. Then shoreline erosion, if this is baseline data as well as after construction what happens, that also can be carried out. We have the satellite imagery. By comparing the satellite imagery, we can predict the shoreline erosion. I told about this comprehensive and rapid EIA. The rapid EIA and comprehensive EIA depends mainly on the shoreline erosion. Suppose the erosion is more than 1 meter per year, in those cases you have to necessarily do the comprehensive EIA. Suppose the erosion is nil, negligible, maybe 1 meter in over a period of 10 years, then we may not have to do the comprehensive EIA, we can do with the rapid EIA. This point is clear when we do the rapid EIA, when we do the comprehensive EIA. Already there are locations where erosion takes place. We know also the rate of erosion. So, if the rate of erosion I have given 1 meter per year, I am not sure whether it is correct, but there are certain values fixed. The erosion rate is higher than this baseline value, then we have to do the comprehensive. Then dredging and its disposal, we have to study the bathymetry and the seabed characteristics. Then we have to do the water quality parameters. This is very important. Why water quality parameter is important? Why water quality parameter is important? Huh? Marine?
Marine growth.
Marine?
Marine growth. Fishes.
Marine growth, if it grows, why we have to design the structure? It is for the fish.
Biofolic.
Not biofolic. Biofolic and all is for scientists and researchers. The local fishermen, the problem is with the fish community. What happens to the fishes? See, you know this Kudangulam atomic power plant and many thermal power plants. The fishermen are telling, if you are bringing in water from sea and then use it for cooling and letting it off, the temperature will increase. Typically the temperature will increase by 7 degrees. So, what we can let into the sea is not more than 7 degrees, but there are certain state government, they are telling it cannot be more than 5 degrees. Suppose you are taking the water at 28 degrees for cooling water purpose, then you are cooling the boiler and other thing and you are lifting it out. If it is 33 degrees, it is permissible. Suppose it goes to 35 degrees, in certain regulation, certain year, it is permissible. It should not be more than 7 degrees. So, what happens if it is more than 7 degrees? Fish will die because it cannot resist the temperature, ambient temperature. There is some location where we are asked to do some measurement, we are not even able to do the measurement because it is very hot, we cannot go and stand there. So, if it is increasing, what can be done to reduce it? You are bringing the water, you are cooling the boilers, you are letting out the water temperature is high. How to reduce the water temperature?
Expose it to air.
Huh?
Expose it to the environment.
Not exposed to sea environment.
No, air environment.
How to expose it?
Give more area to.
How to do that?
Give more area for the water to get exposed to the air.
So, it is called as a pre-cooling channel or a basin where whatever you are telling only, what they do is there is a channel, pre-cooling channel, we make a very long channel, by the time the water goes through the channel and then you let into the sea, then the water will be, temperature will be reduced, or is keep it for 24 hours, then you remove it. You have a storage area where you keep the water for 24 hours exposed to open environment, then it will reduce the temperature, then you can let it out, okay. It is also possible. Mainly it is about temperature, turbidity, pH, salinity and dissolved oxygen. This biochemical oxygen demand, ammonia, inorganic phosphate, cadmium, lead and mercury. These are some heavy metals concentration. This is also very important. They do not want this heavy metals to be distributed. So, now we will be discussing about a port which is being constructed now. This place is called as Gopalpur. This is in Ganjam district in the state of Orissa, adjoining the state of Andhra Pradesh. We have to study the coastline for about 22 km between the port location and there is a river mouth called as Rishikulya river mouth. So, this is the port, this is the Orissa state, this is the AP state, the port is somewhere here, this is the Chilka lake. So, this is very close to the Andhra border. We want to study about 22 km stretch on the northern side of the port where there is a Rishikulya river. So, this is the port what is being built, this is the eastern side. The color code as usual indicates the darker the color, the deeper is the water depth. There is one breakwater being built here, southern breakwater, this is the northern breakwater. There are a series of groins which are built to reduce the erosion, and this is the channel and this is the harbour basin area where we will be doing the dredging, and this is the area where we use the silt trap or sand trap which will be collecting the sediments, and this is used for maintenance. You remove the sand from here and then dump it on the northern side. That is what we do as an environment management plan. So, many ports when you talk about, they consist of the following. One is a breakwater. So, I already told you how to design the breakwater, already this discussion has been done how to design a breakwater. Then berthing structures, we have done for a typical structure how to carry out the analysis. Now, one more lecture I will be discussing about the design of piles, beams and slabs. Mostly it is civil engineering, but anyhow I will give some construction methodology along with the design so that you understand the components of this berthing structures. Then berthing area, we have to do the dredging and disposal. The berthing structure is on the land side, the berthing area is in the harbour side. Then how to develop the backup area, then development in hinterland, that is a road, rail and pipeline or inland water transport connectivity. So, we have to study various alternatives before selection of project and its location. This is what is to be done. Backup area means where you store the stacker, reclaimer and all you are using. No? I told about 1.5 hectares is required for 1 million tons of cargo approximately, it goes up to 8 hectares if it is wheat, fertilizer and all. So, if you have a 10 million tons of cargo to be handled, about 20 to 30 hectares area is to be developed, the backup area. Then you need the road, rail and other connectivity, water supply, pipelines and all those things. Development of hinterland is from where you get the cargo, origin and destination. So, where the cargo is coming from. If you take the Orissa, if you are taking the coal from the mines, it has to come to the port. So, there is a traffic density that has to be studied. Mainly this before selection of project and its location is, if you take the Gopalpur, it is very close to the NH and railway line. The main thing what is to be decided is whether it is very close to the national highway and the railway line. So, you have to put only a feeder line from the railway line and the road network, that if it is very close by, whenever you put a roadway and a railway line, you have to cut lot of trees, you have to acquire lot of lands. So, if that distance is minimal, the environmental disturbance also will be less. Another thing is how close it is to the origin. Suppose you take the coal and iron ore which are to be exported. Now, what is being planned to be exported from Gopalpur is either going from Vizag or Chennai or Calcutta. So, these three places are far away from Gopalpur. So, the lead distance will be less. Then there are some steel plants for JSW, Tata and all, for they will be importing some coal, different type of coals are there. Some coal they will import, they will also export the finished steel products, that is also very close to Gopalpur. Then construction material is another area which is being planned to do the export. Then we have Indian Rare Earth Metal, Indian Rare Earth Limited. This is the atomic power plant, nuclear related industry, which is very close to Gopalpur. They mine these sand mines in Gopalpur and they take the rare earth and then they will export. So, that is also adjacent to this boundary. The environmental study, mainly we have to talk about the fishery resources in the area. So, if you see after agriculture, most of the population in India, they are living on fishery resources. These are the two major components from which they get the income. So, we have to take care of this fishery fisherman's livelihood. Then we have to talk about the coastal and marine ecosystem. This can be backwater, this can be mangroves, this can be this olive ridley turtle which is going through the Rushikulya river and things like that. Then the impact of breakwaters on shoreline stability, this we already discussed, what happens when you build a breakwater. Then impact of dredging and dredge spoil disposal. We have to give the recommendation on mitigation measures and we have to prepare an environment management plan and then carry out. See, apart from all these things, I may forget this, we have one more, this is not related to EIA EMP, this is something. What do you know about this CSR? What is CSR? Corporate social responsibility. This is also very important. If you see the Kodangulam power plant, Tamil Nadu government has given 500 crores as corporate social responsibility, see, to solve the problem of the local people. This government they have given 150 crores, central government. These are all corporate social responsibility to take care of the people's requirement over and above the normal development. So, this corporate social responsibility also should be considered whenever you develop a port project. Typically they want about 5% of the total cost of the project to be used for corporate social responsibility. So, this is breakwater is built to break the force of waves and protect surrounding land, and this prevents beach from getting eroded by destructive waves, protects the area behind from the beach from storm surges. This is the purpose of the breakwater. The impact on breakwater, this can be on various counts. One is the quarry operations. This leads to reduction on forest coverage, because we will be removing the forest cover, then we will be removing the stone from the quarries. On completion of quarry operation, forest coverage can be reinstated. This is the management plan. So, this is the impact, this is the management. There will be dust and noise pollution due to quarry operations and transport of materials, and the dumping of stones disturb marine ecology and fishery, but these effects are temporary in nature and can be reversed. Whatever destruction it is doing, it can be reversed. It cannot be completely eliminated, it can be minimized. There will be some impacts, but we can minimize the impact and we can reverse the impacts at a later stage. Then we have to build the construction of the jetty. This is the initial stage. This is the breakwater which is built in Gopalpur. They are going to start the piling work here. This is the gantry which they have erected. They will start piling here. What will be the impact on quay wall? Some spillage of construction material only is the impact. The other effects are noise and dust. These are all temporary in nature. So, in IIT Madras, if you see most of the construction sites, we are putting a barricade, so that one purpose is you do not see what is going inside, another purpose is the dust does not come out, and another thing what we have done is for construction we have a gate near Mandagini hostel through which we get all the construction materials. If you are getting it from the main road, getting in Gandhi Mandapam road is very difficult for the lorries to come first. Second is it will come through the campus area, the road will be spoiled and there can be some accidents also. The next one is the dredging operation. This is the entrance channel and this is the harbour basin area, how we are going to dredge this material. Here I have shown two curves, one is in red color, another is in blue color. These two color indicates what happened to the shoreline over a period of time. Even without any construction, some effects have taken place. So, these are the three dumping locations what is shown here. we are showing the latitude and longitude. The bathymetries are shown here 0 to 5, it is 0 to 5, 5 to 10, 10 to 15, 15 to 10 and all. I think we are doing it 5, 10, 15, 15 meters, 20, 25. In the 20 meter contour at 3 locations we are dumping the material. So, when you want to do the measurement, this is called as a lagoon harbor, this is the existing harbor. So, for baseline data you have to collect the samples, water quality samples or temperature measurements, we do it at these locations, so that you can come back and do the measurement at a later date and compare what happened to this data with the baseline data. So, out of 8 million cubic meter of dredge material, 2 million cubic meter is disposed on the northern side, which is nearly about 8 kilometers from the center of the harbor basin. So, this is 1/4 is dumped on the northern side as a stockpile, so that the erosion what will take place will be minimized. Balance we are disposing it onto the sea. The disposal site is at 25 meter water depth, and geographical coordinates are given, so that with the GPS the dumping barge can locate these points. So, before dredging we have to take the samples and analyze for presence of toxic materials and obtain basic data. This is very important. Suppose there are some toxic materials, you cannot dump it on the shore. Northern side we are putting 2 million cubic meter. If there is some toxic materials there, you do not dump it on the northern side, you can either dispose it onto the sea, or you have to have a separate place where you can dump this toxic material. So, you have to study the sample for that. This aquatic ecosystem, what is the disturbance it will carry? There is a place called as Dhamra, which is on the northern side of Orissa state, where L&T has built a major port, L&T and Tata together. Most likely it is going to be taken over by Adani Ports. Adani Ports is from Gujarat. So, the corporates are changing. Started with L&T, then they had a joint venture with Tata. Now, most probably it may be taken over by Adani. At this place Dhamra, we have all this olive ridley turtle and all. So, when they want to do the dredging, they put what is known as a turtle deflector. They are attached on the drag head. Drag head means the head which removes the sample. They put the turtle deflector. So, they have found out that this turtle deflector will not kill the turtle, and it will make the turtle to move away from the place where they are dredging. This has a penalty that the dredging rate will be reduced, but anyhow this has been given as a system which will be used to do the dredging at that particular area. So, that is what I have given. This causes disturbance to aquatic ecosystem. You have to make certain arrangements to minimize the disturbance. If there is toxic materials, then you have to dislodge this in you have to make a separate area where we can dispose of the toxic material. We put what is known as this fabric, geofabric, the geotextile cloth, so it does not penetrate inside the soil medium. You make a excavation, put special materials, so that you can dump this toxic material and then close it at a later date. This is about the benthic substructure. This is some fishing and other biofouling activity. Then it will increase the turbidity, which can affect the aquatic species metabolism and interfere with the spawning. So, to avoid this, what we can do is we can reduce, we will see that the dredging is not done during the spawning period. That is one activity which can be done to reduce the impact. So, we have to toxic materials means to be contained and disposed of carefully. Fishery can be reversed except in the operational areas. Operational area means where you are using the ships for berthing and deberthing. All other effects what is described earlier are minimal and temporary in nature. So, these land areas what we are developing will benefit to the port and the society, that is a positive impact what we will be having due to this development. So, with this this part is completed. So, if you want to be a good engineer, you should know how the failure will take place. There are basically two type of structures, a civil engineering structure. One is called as a column, another is called as a beam. What is the difference between a column and a beam? Column is, what is it? Vertical load, axial load. What is beam? Horizontal load, transverse load. See, column is generally it is called as a axial load. It can be axial compression or tension. Beam is bending and shear. See, typically you have a 3-axis system. Suppose you have a member here, this member may be subjected to some force here, this is called as axial force, some force in this direction, this is called as a shear force, some force perpendicular to this, that is another shear force. So, you will have 3 forces and 3 movements. So, you will have a movement like this is called as a bending moment. What about the movement about z axis, what is it called? Torsional movement. So, this movement is about the x axis, this is about the z axis, then you will have one more movement about the y axis. Typically you will have 3 forces and 3 movements. One is an axial force, other 2 forces are shear forces. Bending moment, there are 2 bending moments about the major axis and another is a torsional moment. Torsional moment is like a axial force. Any member will consist of all the 6 forces. In some places some of the components will be 0, in some members some of the components will be very less. There is a provision when you can design it as a column or beam, but generally for a major structure we have pile which will be designed as a beam column and there is a beam and slab which will be designed. So, we will have 3 more lectures, video lectures, one is about the pile, another is about a slab. The difference between the pile and the normal column what you see in the multi-storied building is, these piles generally have large unsupported length. What is there in the ocean structures? This will be your bed level, this is called your wounding level. This is your bed level, this is your water level which varies, then we will have the deck here and this is your unsupported length, this is your embedment length. Then you have a fixity point, this is called as a virtual fixity depth because this does not exist. These are the various parameters. So, when you talk about the column, there are 2 types of column, one is called as a short column, another is called as a long column. What is the difference between short column and long column? Huh? What is it? What is aspect ratio?
8.1 to 5.
Huh?
8.1.
8.5? I don't know what is that. So what is L here? What is L here?
Unsupported length.
Unsupported length is not correct. Unsupported length is not correct. First length, then effective length. What is the length here? I have written so many lengths, virtual fixed depth, embedment length, unsupported length, all those things I have written. What is the length here? Whole length is not correct. Whole length means from here to here. That is not correct. Huh? That is total length. I said it is not correct. Yeah, that is the length. This unsupported length also is not correct. You have to take to the center of the pile and take it right up to the fixity point, and this is considered as restrained against rotation but allowed to displace, right. So this is the actual length, this is called as L. We have to talk about L effective. L effective is some factor into the length. What is this factor? Huh? Greater than 1. Even 100 is greater than 1. Greater than 1 is correct. 2 is not correct.
1.67.
Root 2 is also not correct. It is 1.2 L. Why this is coming here? Why this effective length comes into picture? When effective length is equal to the actual length, what condition effective length is equal to the actual length? Huh? Both and pin. What about mechanical engineering students? You have studied this effective length. For what condition it is 2? Somebody told 2. Huh? Huh? Both end engine is L equal to 1. L effective is equal to 1 L. Huh? Both end fixed is not 2. Both end fixed cannot be 2. Cantilever. So you have 3 cases. One is hinge, another is cantilever, the third one is both end fixed. Both end fixed, it takes buckling, this is called as buckling. So this goes like this. So you can bend and go like this. That is how this becomes 2L. Effective length equal to 2L. Here it is L. Here it is 0.67 L. So our case is this is fixed against rotation and deflection, whereas this is fixed against rotation. Rotation is 0, but it is allowed to displace. So you have to take the L effective. What happens is when you kept a load like this, the load will displace for a distance p. Actually the load will act at an eccentricity of delta. This is called as P delta effect. Okay. Nowadays you can do what analysis known as a P delta analysis. If you do a P delta analysis, you do not have to take the additional moment. If you have to do the slender column you are telling L by D ratio. Apart from L by D ratio, there is another ratio, it is called, what is that ratio? What other parameter you can take instead of L by D? The slenderness factor is called as L by D. There is one more parameter, not L by D. What is that? Huh? So L by D ratio, there is another ratio. Huh? KL and all is quite D. Instead of D, they use some other parameter. What is that? P or D, whichever is smaller, you have to use. 2 directions, you will get 2 parameters. They do not use D, they use some other parameter, length parameter. What is that? I do not know why you do not know. This is called as L by R. What is R? Radius of gyration. Root of I by A you have to use. Better way is to use L by R only, not L by D. So there is a limit. L by D, I think 12 is the limit for short column. If it is more than that, you have to Suppose there is a column which is subjected to a load and a moment. Generally these piles are subjected to axial load, bending moment and shear force, right. We have to design the pile for all these things, that is what we are going to do now. This is the table which will come after doing the beam data analysis. It gives Fx, Fy, Fz, Mx, My, Mz. We get maximum and minimum in forces as well as for bending moments. So we will have the axial force Fx, shear force Fy, Fz, a torsional moment Mx and bending moment Mi, Mz. If you do a finite element analysis, there are two coordinate systems used. One is a global coordinate system in which you place the structure, another is a local coordinate system in which you take the member. For that member the directions are given like this. Typically for this member we do not give this axis. Suppose this is your member, the local coordinate system, this what is drawn may be the global coordinate system. The member joining these two nodes, it is generally called as x and this y and z. This is the local coordinate system, that is why Fx has become the axial force. So you get this, but I said you will have 100 load combinations, from that it will give these values. So these are the piles which are being built during construction stage. This is the roller over which the pile is moving. This is the axial load on pile what is coming. This is the bending moment for one load combination. So this is the founding level up to which we have done the analysis using the springs here. This is the maximum moment that is coming at the center line of the beam column junction. Then this is called as the envelope. The envelope means it gives for many load combinations what happens to the bending moment diagram in different directions. So at this level you will have either movement this much or this much. If you take this level you will have this much movement on one side and this much movement on the other side. So you have to design for all these types of bending moments. So when you talk about the axial load for this particular case the bending moments are nearly 0, we have the axial load of about 700 tons. It is a very huge load. So whenever we get this type of load we have to talk about two types of design. One is the structural design, another is a foundation design. Foundation design is always having certain risk factor associated with that. We normally what we do is we do a pile load test, actual pile load test we do and ascertain that this load it is capable of.
So how will you do pile load test in here?
We do it.
In sheet?
See, I will tell you how they will do it. I have a PowerPoint presentation, we will discuss separately on that. There are many methods are there. There is a cantilage method is there where they put actual 700 tons load, that is done normally on land. Otherwise they do anchors.
So plate load test is the same?
They put anchors right below that and then put a jack. Jack will pull the anchor and distribute the load. The third one is nowadays they do what is known as a high strain dynamic test. That means there is no cantilage. Suppose 700 tons is the load, 1.5 times you are doing, they drop a 12-ton hammer from some distance, they get the response, from that they predict the capacity. Actually we have to do this before construction of the facility. This we do a test pile separately and then the load and then see. I am recently designing one bridge for Indian Maritime University near Buckingham Canal. There we wanted about 500 ton capacity, the pile load test has given only 450 tons capacity. So number of piles we are revising it before construction. The initial load test we have to do, it is very important. So these are the various levels which we have. This is called as a PCL, means pile cutoff level, dredge level and founding level. When you want to design the pile we have the overall diameter, we have what is called as the effective depth, that is from the compression phase to the central line of steel. Then we have the cover, this is called as the effective cover. Clear cover is from here to here, then effective cover is shown here. We have to assume the diameter of the pile even before starting the analysis I told the span by depth ratio can be around 12 to 15 for the piles. We have to assume the grade of concrete. Nowadays we use 500 yield steel, clear cover is 75, diameter is 32, then this is cover plus diameter by 2, this will be the effective cover. Nowadays the clear cover is defined as a clear cover from the distribution steel. Earlier days it is designed as a main steel, now it is from the distribution steel. So that means you have to add cover, clear cover plus distribution steel is 12 mm plus diameter of bar by 2. Then you have to calculate a factor called as d dash by d. Then you have to find out these two factors Pu by FCK d square and Mu by FCK d cube. This we are using it to get it from the chart SP16, the chart number 56. You go to the chart, this is the chart which gives Pu by FCK d square in one axis, another axis you get Mu by FCK d cube. Here it has shown the grade of steel, here it has shown the d dash by d ratio 0.1. What it finally gives is the percentage of steel is written here. What it shows is these numbers what is marked here, these are P by FCK, it is written here P by FCK, percentage of steel divided by strength of concrete. So the earlier case Mu by FCK d square is 0, Pu by FCK d square is 0.14, so 0.14 is here, somewhere here, that means we do not need any steel that is what it shows. But if that point comes somewhere here, let us say typically we do not want to put anything more than 0.1, the typical level what we use is 0.5. Suppose this point is there, this is about 0.02. So for those who have not used the thing, I will just write down, we will have what is known as Pu, what is known as Mu. What you do is you calculate Pu by FCK d square, you calculate Mu by FCK d cube. You go to the chart and find out what is known as P by FCK. Approximately this is equal to 0.03 it is coming. P will be 0.03 into FCK is 35. So it comes around 1.05%. So AST will be 1.05 by 100 into pi into 1200 id square by 4. What we are finding out is what is the area of steel to be provided. Is it clear? The design what we are calculating is how much area of steel we have to provide, how many number of bars we have to provide, that is what we are calculating. Is it clear or not clear? From the analysis you get the axial force and bending moment. If you have not done the B delta analysis, the bending moment you have to add additional moment due to eccentricity. If you done a B delta analysis, you can take the moment directly, calculate P by FCK d square and Mu by FCK d cube and go to the corresponding chart. This chart is having d dash by d is equal to 0.1. If the cover is more, d dash by d can go to 0.15. The diameter is less, also d dash by d may increase. So based on that you get all these values, get P by FCK. There is one more value given here. Suppose your point lies here, that means your stress in steel is this FYD, that is the stress in steel. If it is 415, if the point lies here, the steel is yielding. Suppose the point lies somewhere here, the stress in steel is 0.8. Suppose if the point lies here, the stress in steel is 0.6. So you can get the stress level in the steel also. Typically the stress level in the steel shall be kept less, right. So we have one more case, that is your axial load and bending moment. Since it is a circular section, you can get the resultant moment. Now you go to the chart, you get 0.02, then you get a steel of 0.7%. So it is 0.05 and 0.06. So we will see this here. This is 0.06 somewhere here, and this is it is not coming all right. The 0.06 and 0.05. So this is 0.06, it is given here, and this is 0.05, that is between 0.02 and 0.04. So they have not written correctly, it is somewhere around 0.038. So, this is not correct, it is 0.038 and percentage of steel will become about 1%. Typically we have to get this between 1% and 2%. This there is a code called IS 2911 which says that the minimum reinforcement should be 0.05, but we are providing more than that, we are providing 0.7%. So, once you put 0.7%, it shows each diameter of 32 mm bar is 804 millimeter square. So, you put 10 bars, that is what is required. Then you have to calculate the clear distance between the bars, this should be more than 100 millimeters, that is another thing which you have to see. Then about the lateral ties, you have to find out what is the diameter of the bar pile, that is the distance between the lateral ties. So, finally what we are doing is how many bars are to be provided, number of bars. The clear spacing between the bars should be more than 100 millimeters. This is the inner bar is for holding the bar in position, that is typically about 16 mm bars are provided at 1500 millimeters center to center. The outer bar is the lateral tie. The spacing is limited by 3 considerations, that is what is shown here: diameter of the pile, 16 times the main bar, 300 mm center to center, and the diameter of the lateral tie should not be less than 1/4 the maximum diameter of longitudinal bar. These are given in IS 456, based on which we design what is a lateral tie, Y12 at 100 center to center. You can see how they are tying the bars, they are transporting by barges, they are lowering it into the pile. This is the cover block, this is the liner what is already driven there, this is concreted up to this. The top concrete will generally be not good, they remove some top concrete here. You have to provide these bars, lap bars, so that you can connect it to the beam section. So, this is the reinforcement detail for the pile cap. Okay, see you next class.